Hello Algebra 2 students, welcome to section 11-3 Fundamental Trigonometric Identities. In this section you're going to learn how to use fundamental trigonometric identities to simplify and rewrite trigonometric expressions. Also you're going to learn how to prove other identities, how to verify other identities. Although you are not required to verify the fundamental trigonometric identities, but it's very useful to figure out how did we get them before start using them in simplifying and rewriting trigonometric expressions. The fundamental identities are divided into four groups. The first group is called reciprocal identities. In earlier section you studied that cosecant and sine are reciprocal to each other. So cosecant theta is equal to 1 over sine theta, or it can be written sine theta is equal to 1 over cosec theta. Secant and cosine are reciprocal also, so secant theta is equal to 1 over cosine, or you may start with cosine theta is equal to 1 over sec theta. Finally, cotangent and tangent are reciprocal to each other, so cotangent theta is equal to 1 over tangent theta, or you may start with tangent theta is equal to 1 over cotangent theta. The second group of the fundamental trigonometric identities is called tangent and cotangent ratio identities. Tangent theta is equal to sine over cosine. How can we prove this identity? Guys, based on the definition of the sine and the cosine, if I start with the right hand side, sine theta over cosine theta, the definition of the sine ratio is opposite over hypotenuse. And cosine theta is equal to adjacent over hypotenuse. If you cross out the hypotenuse from the numerator and the denominator, you will end with opposite over adjacent. Opposite over adjacent, this is exactly the tangent ratio, tan theta. So we started with the right hand side, sine over cosine, and we prove it equal to tangent theta. This is exactly our first tangent ratio. The cotangent ratio is opposite to the tangent ratio. Based on the reciprocal identities, guys, you know that tangent and cotangent are reciprocal to each other. Since we have proved that tan theta equals sine over cosine, so definitely cotan theta is equal to cosine over sine. Or you can use the same way the definition of the cosine and the definition of the sine to prove cotan theta is equal to cosine over sine. The third group of identities in this table is the most important one and is called the Pythagorean identities. The first Pythagorean identity, cosine square theta plus sine square theta is equal to 1, is the most famous identity in trigonometry. And we can derive the other Pythagorean identities from this one. So how can we prove this one? How did we get this one? Guys, do you remember the unit circle? In the unit circle, the radius of that circle, r, is equal to 1. If you take any point on the unit circle with a coordinates x and y, the length of this vertical side gonna be y, and the length of this horizontal side in this right triangle gonna be x. If you apply the Pythagorean theorem, this leg square plus this leg square is equal to the square of the hypotenuse. So it's gonna be x squared plus y squared is equal to 1. But remember, we are in the unit circle. On the unit circle, the x coordinate represent the cosine function and the y coordinate represent the sine function. If we substitute that in this equation, we get cosine square plus sine square is equal to 1, and this is the most important Pythagorean identity. How do we get the second one and the third one? Guys, I can use the first one to derive the second one and the third one. Let's start with the first Pythagorean identity, cosine square plus sine square is equal to 1. If we divide the whole identity by cosine square theta, we will get the following. Guys, if you divide cosine square by itself, you will get 1. If you divide sine square theta by cosine square theta, sine over cosine, this is tangent square theta. And finally, 1 divided by cosine square, the reciprocal of cosine is secant square theta. This is exactly the second Pythagorean identity. Same with the third one. I can start with the basic or the first Pythagorean identity, cosine square plus sine square theta is equal to 1. I can divide every term in this identity, this time by sine square theta. If you divide cosine over sine, cosine squared over sine squared, this is exactly cotangent theta. Cotan square theta plus sine over itself, sine square over sine square, this is exactly 1, is equal to 1 over sine square. The reciprocal of sine is cosecant square theta. This is the third one, guys. So we have verified the 3 Pythagorean identities. Guys, be flexible when you use the 3 Pythagorean identities. You can derive 2 more forms from each one of them. What I mean is, if you want to isolate this cosine squared theta, cosine squared theta is equal to, you can minus sine squared theta from both sides. You will get 1 minus sine squared theta. This is another form from the first identity. If you want to isolate the sine squared theta, sine squared theta is equal to 1 minus cosine square theta. So whenever you see 1 minus cosine square, you can replace it with sine square theta. It's the same idea or the same identity but different form. Same with the second one. If we want to isolate tangent square theta, we minus 1 from both sides. So we're going to have tangent tan square theta is equal to 6 square theta minus 1. Another form. Same with the last one. If we want to isolate cotangent square theta, we can minus 1 from both sides. So cotangent square theta is equal to cosecant squared theta minus 1. So many forms can be derived from the same Pythagorean identities, and the most basic one is the first one. We get the first one from the unit circle. The last group in this table, guys, it's the non-negative angle identities. Let me free some space in order to explain how did we get the angle identities. The first negative angle identity says sine the angle negative theta is equal to negative sine angle theta, the opposite of the sine angle theta. Second one, cosine angle negative theta is equal to cosine angle theta. They are the same. Third one is similar to the first one. The first one and the third one are quite similar. Tangent the angle negative theta is equal to negative outside tangent theta. So guys, in the first one and in the last one, it seems like we take the negative sign outside the sine and the tan ratio. But how can we prove that? How can we understand that? Guys, take the angle theta in the first quadrant and the angle negative theta in the fourth quadrant. This is quadrant 1 and this is quadrant 4. Guys, if you calculate sine angle theta in quadrant 4, remember sine theta, it means the y coordinate. Y is negative in quadrant 4. So sine angle negative theta is negative y. What about sine angle theta? Sine angle theta in quadrant 1 is y. This negative y is exactly the y, the opposite of the y. So you need to take this negative sign outside. So sine angle negative theta is the same as the opposite of sine theta, and same with the tangent ratio. Guys, do you remember the tan angle theta? Tan any angle is the y coordinate over the x coordinate. So tan angle theta, tangent angle negative theta in quadrant 4 is equal to negative y over x, because y is negative. What about tan angle theta? Tan angle theta in quadrant 1 is just y over x. So what is the relationship between this quantity and that quantity? They are opposite to each other. So tangent angle negative theta is negative tangent angle theta. What's happening with the second negative angle identity? Cosine negative theta is equal to cosine theta. Why they are equal? Guys, let's find cosine angle negative theta in quadrant 4. When you talk about the cosine function, you're talking about the x coordinate. So cosine negative theta is equal to x. What about cosine angle theta? Cosine angle theta in quadrant 1 is also equal to x. Remember guys, the x coordinate is positive in quadrant 1 and in quadrant 4. So cosine angle negative theta is equal to cosine angle theta. Both of them is equal to x. We call this group of identities the negative angle identities. Guys, now let's take a look in a couple of examples that involve some of the fundamental trigonometric identities. How can we use them in problems to solve problems? Before I start solving problem, guys, let me advise you a couple of advice. Number one, if you want to prove an identity, if you want to identify any identity, my advice is start with the most complicated side. Don't start with the easy side, because most probably nothing to be done with the easy side. Like in part A, we need to prove tangent angle theta is equal to sec theta over cosec theta. What can be done to tangent theta? Tangent theta is a basic trigonometric function, but we can do some work on the left hand side, on the right hand side, secant theta over cosecant theta. So guys, my advice is to look for the most complicated side. Another advice, guys, whenever you see reciprocal identity or negative angle identity, start with this. Your problem gonna be easier, opposite to your expectation. Let's take a look. In part A, we need to prove tangent angle theta is equal to sec theta over cosec theta. Guys, let me start with the right hand side. The right hand side in this identity is equal to sec theta over cosec theta. What can be done to secant theta and cosecant theta? Guys, everybody knows that sec is the reciprocal of cosine. So I can replace this numerator with 1 over cosine theta. Let me replace this fraction bar with the division symbol. Cosecant theta is the reciprocal of something. It's the reciprocal of sine. It's 1 over sine theta. Guys, we can turn this division operation into multiplication by the reciprocal. So we can copy 1 over cosine theta, but multiplied by the reciprocal of 1 over sine theta, which is sine theta over 1. When we simplify this, 1 times sine theta, it's sine theta on the top, and cosine theta down. Guys, sine theta over cosine theta, this is exactly tangent theta. This is the definition of the tangent ratio theta. Guys, this is exactly the left hand side. We started with the right hand side and we end with the left hand side. So we have proved secant theta over cosecant theta is equal to tangent theta. Congratulations. Another part. 1 minus cotangent theta is equal to, we need to prove that, guys. 1 minus cotangent theta is equal to 1 plus cotangent negative theta. Let me start with the most complicated side, which is the right hand side in this identity. So the right hand side is equal to 1 plus cotangent negative theta. But we didn't study cotangent negative theta. We studied tangent negative theta. Do you remember, guys, the angle identity tangent negative theta? It's equal to what? It's equal to, you take outside the negative sign, and negative times tangent angle theta. So why not replace this cotangent theta with its reciprocal and apply what we learn in the negative angle identity? So this is going to be equal 1 plus. And instead of cotangent, I'm going to make it 1 over tangent negative theta. We studied identity for that. That's 1 plus 1 over tan negative theta is negative tan theta. You studied this identity, guys. And now plus times minus simplifies minus. So it's going to be 1 minus 1 over tan theta. Let me bring tan theta back to its origin. So it's going to be 1 minus. What is the reciprocal of tan, guys? The reciprocal identity of tan, it's cotangent. So this is 1 minus cotangent theta. This is exactly the left hand side. So guys, did you notice I started with the right hand side and I end with the left hand side? So I have proved this identity true for all theta values. Another idea. Rewrite each expression in terms of cosine theta. Guys, I need my answer to be written in terms of cosine theta. So whenever I meet cosine theta, I will leave it. And whenever I meet any different thing, I will replace it as much as I can with cosine theta. Let's start with part A. Secant theta times 1 minus square theta. Guys, what can be done with the secant? Secant is a reciprocal of cosine. This is very nice. This is what I need. So I'm going to replace secant theta with 1 over cosine theta. Times. Guys, does this parenthesis look familiar? 1 minus sine square theta. Do you remember the Pythagorean identity? The first one, sine square plus cosine square equals 1. And we derived two different forms for this one. Do you remember when I said if you want to isolate the cosine square, it's going to be 1 minus sine square theta? So 1 minus sine squared theta can be replaced with cosine squared theta. This is awesome. Guys, we can cross out 1 cosine theta from the top. We can cross out this square with 1 cosine theta from down, and we left with cosine theta. This is my answer in the simplest form in terms of cosine theta. Another part. Sine theta, cosine theta times tangent theta plus cotangent theta. Guys, it looks difficult at the beginning, but once you start substituting and using the identities, you will get what you need. So be patient. Sine theta, cosine theta. Nothing can be done with sine theta, cosine theta. Let me copy that. Sine theta, cosine theta outside the parentheses. I have a lot of work to be done inside the parentheses. Guys, tangent theta can be written. Yes, absolutely correct. Sine theta over cosine theta. What about the cotangent? It's the opposite. It's cosine over sine. Now guys, I can use distributive property. I can multiply sine cosine times the first term one time and times the second term. This is what we call distributive property. So guys, I have sine theta cosine theta is multiplied by, the first term is sine theta over cosine theta plus the same quantity outside sine cosine, sine theta cosine theta multiplied by the second quantity in this parenthesis, cosine over sine. Cosine over sine. We have a lot of things to simplify, guys. Cosine theta from the bottom, cross out cosine theta from the top. Guys, we left with sine theta times sine theta. This is exactly sine squared theta plus. Also, we can simplify sine theta with sine theta, and we left with cosine theta times cosine theta. This is exactly cosine squared theta. Does it look familiar? What is sine squared plus cosine squared, guys? It's 1. And this is the simplest answer of this problem. Let's end this, guys, with a physics application. This physics application is talking about the equation mg sine theta. There is an equation mg times sine theta is equal to mu. It's a Greek letter. Mu, it's a factor of something called friction. Mu times mg cosine theta. To determine the angle, so our job is to determine the angle. Our job is to find the measure of angle theta at which a waxed wood block on a wood incline with mu is given. This friction factor is given, mu equals 0.4, begins to slide. Guys, to understand the idea of the problem, we have a waxed wood block like this, placed on a inclined surface like this, and it's stable, it is not moving. But when you increase the angle theta at particular value of theta, this piece of wood gonna start slipping down, gonna move. And our job is to figure out this value of theta with mu equals 0.4 when the friction factor is equal to 0.4. Guys, as a beginning, I can divide both sides by mg. If I divide this side by mg, because it's common between the two sides, I can cross out mg from both sides. So guys, we left with sine theta is equal to mu. Mu is given, it's 0.4. 0.4 times cosine theta. How do I find theta? I have two trigonometric ratio, sine on the left hand side and cosine on the right hand side. Guys, is it possible to combine them in one trigonometric ratio? Think. Yes, we can divide both sides by cosine theta in order to get one trigonometric ratio is equal to a number. Cosine theta and cosine theta cross out each other. What about sine theta over cosine theta? This is the definition of the tangent ratio theta. So tan theta is equal to 0.4. But I need to get the measure of angle theta. Do the inverse operation. It's the arctan or the inverse tan of 0.4. What angle? Its tan ratio is equal to 0.4. Put it in the calculator, and the calculator gonna give you the measure of angle theta is equal to, if you approximate that to the nearest degree, it's gonna be 22 degrees. So this waxed wood block gonna start moving when the angle theta is equal to 22 degrees. Thank you very much. See you in the next lesson. Bye.